So hello all of you. So here we are going to perform the experiment of op-amp for non-inverting and inverting case. Okay, we are going to check that whether we can use the op-amp as a non-inverting amplifier, and in the inverting case also we will verify that case. So here is the image. This is the circuit diagram for the op-amp in non-inverting case. Okay, this is the op-amp acting as a non-inverting amplifier. So our IC is IC 741. Okay, we will perform this experiment in multisim. So just look here in the circuit. Okay, the third pin is being connected to the input power source, and the other part of the source is grounded. Here also we have connected the resistance R1, that is the feedback resistance, and the second pin is connected to the ground by help of this R2 resistor. Pin number 7 and pin number 4 is being connected to plus 12 volt DC and minus 12 volt DC respectively. And from the sixth pin we are going to take the output. So now we will perform our circuit. So firstly I am going to take here the ground. Then we will take an AC voltage source here. We'll change the value afterwards. Okay, now we are going to take two resistances from here. It should be in basic. One is 1 kilo ohm and the other would be 10 kilo ohm. So you could directly search here only. Okay, you could get different resistor. Okay, and you could search the IC directly from here. I'm going to write here 741. So this one is our IC 741. That is the op amp. Okay, so basically these things, equipments and components, we need to perform our this experiment. Okay, so here firstly we will connect our pin number 3 to the voltage source. So I've connected it here. Now I will just connect the other part of this input power source with the ground. Okay, and we will change the value of this voltage, input voltage. So I will take around 100 millivolt only. Okay, take 100 more millivolt peak to peak voltage, and I will take 50 hertz frequency. Okay, okay, it is 100 volt peak to peak. Should be 100 millivolt peak to peak. Now it's okay. Now, as we have seen in the figure, that we have to connect uh, by pin number 2 a resistance. Okay, that is R2. Just check here, R2. So the feedback resistance is of greater value. Okay, so R1 would be of 10 kilo ohm and R2 would be of 1 kilo ohm. So I'm just going to draw here the R2 resistance here, not the R2, sorry, the R1. Okay, so just don't confuse here that here R1 is written and R1 should be higher, of higher value. Okay, and R2 should be of lower value. As in the case of non-inverting amplifier, the gain is 1 plus the feedback resistance divided by this R2 resistance or R1 resistance, whatever the name would be. Okay, so since I am going to connect here the R1, since the in the circuit it is R1 and it should be of greater value, here in the multisim it is R2 and that is of greater value. Okay, so what I could do, I could just change the values here. Okay, so that it may not give any confusion. Okay, so for that thing I will just make this R1 to be 10 kilo ohm. Okay, and R2 I will just make it 1 kilo ohm. Okay, so now look at the figure. Okay, so R1 is 10 kilo ohm and R2 is 1 kilo ohm. So I will connect this. Firstly just move this R2 from here to here and move this R1 from here to here. Okay, so from the output we are taking a feedback resistance here. Okay, and here R2 I'm going to connect. So firstly I will just rotate it. You could rotate the resistance in clockwise or anti-clockwise direction, it's up to you. that will not give any issue. So here I have taken this thing. Okay, now we have to connect this resistor to the ground. Okay, so we could take another ground, or we could simply connect this other part of resistance to the this ground only. Okay, so there is no issue if you are going to connect this resistance in the same ground. Okay, because if you are going to take another ground also, that will act in the same way, in the way that this ground is acting. So you could just directly connect this resistor other part to this ground. Okay, so now I have done this thing. So just check here, we need to connect this R1 before this R2 resistor here. So for basically making it a good circuit, I'm just going to just make this circuit a little larger one. Okay, so that it could look a better one. This thing is okay. Now here I'm just going to connect this R1. Okay, so just look at the circuit. It is connected finally. Okay, so I here in the circuit the R1 is connected directly here. So I have connected it here after second pin. Okay, so both things are same. Understood? So this part of the circuit has been completed. Now I need to give plus 12 volt and minus 12 volt to pin number 7 and 4 respectively. So for that thing I am just going to take here the power source. Okay, I would take VCC, suppose here, and another VCC also here. Okay, so just close it. So both the name is VCC. So firstly we need to change the name here, and then we will change the value, because in a multisim with a single name we can't have two different values of same VCC. Okay, suppose I am going to choose here name VCC1. The value here is plus 12 volt or 12 volt. Just click here no. In this thing you have to choose minus 12, and the label just make it VCC2. Click on the OK button. So now this VCC is needed to be connected to our pin number 7. So just see here I have connected. Now this VCC, second VCC, I will just flip it vertically. Okay. Okay. So now this would be connected with pin number 4. Okay. So just I will move this minus 12 volt VCC somewhat upward. So now this is okay. Okay. Now I would use my oscilloscope here. This is 2-channel oscilloscope. Okay. So one channel I would connect with my output, that is with pin number 6, and the another this input of this oscilloscope I would connect with the power source here. Okay, so just connect here. The one input of this oscilloscope is being connected to the output of this IC, and the negative part of this would be connected to the ground. Done. Again in the second channel also I'm going to connect the negative part of this to the ground only. So I have just connected it here only. Okay, and here this thing would be connected to this input source. Okay, this I have connected so that we could analyze both input to the IC and output of the IC in a single DSO at a single time. Okay, so now we have connected our circuit successfully. Now we will check that what is the input and output of the circuit. Okay, so just run the circuit and check this oscilloscope. Okay, so since the background is dark, that's why it's not easy for us to just see the circuit here, the output here. So I will just firstly reverse it. Now the output color is red in both the case, so that's the reason we are not able to distinguish between the input and output case. So I will just stop this simulation, and I will just change one of the my output color. So we'll do it by changing the wire of the output, okay, or the input. So I'm just going to change the color of the output of this IC. So I will double click on this wire and click on the net color. Suppose I am going to choose here a violet one. Okay, done. Okay, So now my output would be of violet color, and the input of this IC would be of red color. So now again run this simulation. Then here we could see that both red and blue color of the input and output lines are there, and in the channel A and channel B we are getting the information. So now how to check the information here? So for doing that thing, we will firstly stop the simulation. Now when we have stopped the simulation, I am getting this much wave only, so I will just move the scroll bar somewhat here. Okay, now the channel, look at the channel division. Channel A division is 5 volt per division and channel B is 5 volt per division. So since my input voltage is 100 millivolt, so I would need to change the scale of the division. Okay, I'm going to just make it very low here. Okay, and here also. Okay, just make both of the divisions same, or we could just increase or decrease it. So if I'm going to increase it beyond 200 millivolt, it is going outside this scope. Okay, so for betterment, I'm just going to increase the division here, and I will also increase the division to here, to 500 millivolt division. Okay, if you want to view the it clearly, okay, you could just make the division of channel B to a lower part. Okay, so that you could look it clearly. Okay, and for the time scale, you could also uh, decrease or increase the divisions here. Okay, in the oscilloscope. Suppose this one is this wave is looking of a good type. Okay, now so I'm not going to change the divisions now. So now I will check that my what is the input and output voltage peak to peak. Okay, so input voltage is 100 millivolt peak to peak. So our red uh, this input line of this oscilloscope, that is my channel B. It would give me 100 volt peak to peak. So for that thing, I'm just going to use the cursor here. Okay, and you could look here when I'm moving the cursor here. This point is moving on this blue line. Okay, and when I'm going to move the cursor here also, it is moving on the blue line. So if you want, you could just select the waveform for which it would move. So I've chosen the red one, so it would move for the red one. Okay, so firstly, one cursor choose the 0 point. Okay, now for the other cursor I would choose the peakmost voltage. Okay, and I will tell you that how to analyze the output here. Okay, so now this is okay, this point is nearly around 0 0.0 line, and this is at the maximum point here. So this one is channel B or channel 2. Okay, so now look here, this T1. Okay, this first cursor, this T1, look here, the channel B, it is showing 121.014 microvolt. So it is not currently at 0 point, it is currently at 121.014 microvolt. That means it is a very little bit above than the 0 line. Okay, so that is okay. Okay, it will not matter much. And here look at the topmost part, it is currently being present at 99.823 millivolt, this line. Okay, this wave, the highest portion or the voltage peak is 99.82 millivolt. So we have given around 100 millivolt, and we are getting around 99.82 millivolt of peak to peak voltage of this input source. Okay, so we are getting around 100 millivolt. Okay, so there is no need to worry about in on this input part. Now we will move on the output. So in this line only the output maximum part is here also. Okay, since the phase is not changing, that's the reason that the input and output voltage peak to peak lies in the same line. Okay, if you are going to click on this thing also, you could click. Okay, otherwise that is not necessary also. Okay, now here, since this blue waveform, this one is present in channel 1, you could see here in channel A, sorry, not 1, in channel A I have taken the output of this IC. So just check here for channel 1. Channel 1, this uh, starting point is currently at around 12.787 millivolt. Okay, So just leave it. Now just check at this T2 part, which is the second cursor. The highest point is 1.110 volt. Okay, so that means that the highest position of this voltage peak to peak is 1.11 volt. Okay, this is our output. Okay, this is our output. We are getting around 1.11 volt of output when we have given around 99.823 millivolt of signal, input signal. Okay, now there is one another thing which I want to tell you, this T2 minus T1. So this T2 minus T1, for this time part, it is just showing me the difference between the horizontal axis time, okay, of this cursor to this cursor. So if you want to know that what is this difference between this point to this point, you could easily know by the help of this T2 minus T1. Okay, so similarly, if you want to just check that what is the difference between the topmost part and the lowermost part, or something like this part of voltage, you could easily do it by subtracting the voltage division. Suppose I have taken my cursor from here to here. Now for voltage division, that what is the difference of voltage from this point to this point, will subtract the voltage at this point, the peakmost part, to the voltage at this much part. Okay, so we can see here the voltage at T2 is 1.11 and the voltage at this T1 is 469.084 millivolt. So the difference is 640.958. So this is not required for this experiment, but I am just for the sake of learning, I am telling you that when you need to find the difference of voltage, you could do like this. And when you want to need the difference between the time of both the cursor, you could find it here. Okay, so T2 minus T1 is 3.75 currently here. Okay, so just leave this part. Okay, we are not going to change this part. So now just look here in this, in the second line, we have got the output of 1.11 volt when the input was 99.82 millivolt. Okay, so when you will just divide this 1.11, okay, by 99.823, okay, millivolt. Okay, so you will get a value of around 11 point something. Okay, if you'll just divide it, I am just going to divide it. It is 1.11. That means 1111 millivolt. Okay, so if I'm going to divide it by 99, I'm just going to get a value of 11.21. Okay, so this is my gain. Okay, this is voltage output by voltage input. Okay, and if you will verify this thing theoretically, the gain of the op amp, okay, in non-inverting cases, 1 plus resistor feedback divided by this R2. So we can say 1 plus R1 by R2. Okay, so 1 plus R1 by R2 will be equal to 11. Okay, so we are getting that theoretical gain value is 11 and the practical gain value is here 11.21. So these are approximately equal. Okay, so that means that yes, the op amp is acting finely. Okay, it is acting in a better manner when it has been provided plus 12 volt and minus 12 volt, and when we have given here 100 millivolt peak to peak. Okay, so by this experiment we have learned that yes, the op amp is giving 1 plus R1 by R2 as the gain, which is approximately equal to the practical value. The theoretical gain is practically equal to the theoretical value. Okay, so this one is the part for the inverting, non-inverting part. Okay, in the similar manner we will just move to the inverting case also. Okay, so I will just close this part. Just look at here in the as the inverting amplifier. In inverting amplifier, what we do, we just connect the third pin with the ground, and here in the second pin what we do, we just connect the input source to the second pin. Okay, other things remain literally same. Okay, the R1 is being connected to the second pin, and R2 is here, and after R2 we are going to connect here the input source, and the third pin is directly connected to the ground. Okay, so we will now move on to this circuit part, and we will check that whether in this part also the gain is, the theoretical value is equal to the practical value or not. Okay, so now in this case what happens, the gain is minus R1 by R2 theoretically. Okay, so minus R1 by R2, so I'm not going to change the resistance here, and I'm not going to change here the value of input source here. Okay, so minus R1 by R2 theoretically would be 10 by 1, that would be 10. Okay, so it would be, the gain would be minus. Now minus sign is because the signal would be of inverting type. Okay, that means 180-degree phase out. So I'm just going to minimize this thing, and I'm going to convert this circuit now. So for that thing, I'm just going to delete some part of the circuit here. Okay, uh, just wait, just see here what I'm doing here now. I'm going to connect this input source. Okay, after this register here, so you could just move here the register part, and then here this thing. Okay, it looks fine. So I'm connected here the register with my input source. Now I am going to connect it with the ground. Okay, so this part is complete. Now in the circuit we have seen the third pin is also connected to the ground. Okay, so we will connect this third pin to the ground. Okay, so this circuit is nearly completed at this time also. Okay, so here we will again check the output. So for that thing I will connect this thing to the ground, and also the B channel oscilloscope negative also I'm going to connect it to the ground. Okay, other, leave the others portion to be same. Okay, but for checking the input voltage source also at this time I'm going to connect here the positive of B to this V1. Okay, to the positive part of this V1. Okay, so it looks fine. This would be just okay, it looks fine. Okay, no issue in this thing. Now I will just run this simulation once more. Okay, so I have run it. Okay, now we'll see the oscilloscope here. So I will firstly stop the simulation here. Now just check it here. Okay, so these type of waveform we are finding that the output waveform, that is a blue color. Okay, it is being inverted as compared to the input signal. Okay, the red one is the input one, and the blue one is the output one, as I have changed the color of the output signal. Okay, so here also we could check directly that what is the voltage peak to peak of the input and the output. So for that thing I'm just going to firstly check the maximum value of my output. Okay, so it looks fine here now. Okay, so I will check this one to this one. It is not necessary to move the first cursor also. Okay, because we didn't want the division. Okay, sorry, the difference between the voltage of this cursor to the voltage of this cursor in any part. Okay, we just want the maximum value. Okay, so that is not necessary to run this first cursor. Okay, or you could directly move the first cursor only, or and not the second cursor. In that case also you will get the uh, output of this maximum value. Okay, you just need to learn that how to get the maximum value. Okay, since I have moved here second cursor, so just see the second cursor voltage peak to peak. This one is of channel A. Okay, so in channel A, just see here the second cursor. In the second cursor, this T2 we are going to see with the channel A. So this channel A and this T2 combines at this point. So I will get a value of voltage of around 1.011 volt. Okay. So the maximum output value in the case of inverting amplifier is 1.011 volt. Okay. Similarly, I'm just going to take that what is the maximum value of this wave, this negative, this input wave here. Okay, so here I will use the first cursor now. Okay, so that you could learn here also. So I'm just going to click on this wave, the red one, and yes, this one is the maximum point. Okay, so in channel B, since this red one is with channel B, so channel B with the first cursor. So T1 is the first cursor here. So in the T1 with channel B, just move, we are getting the first line only here. So the value is around 99.97 millivolt. Okay, so 99.97 millivolt is the maximum input voltage which is shown by our DSO, and our DSO is showing around 1.011 volt of the output signal which already I have measured. Okay, so these two, when you will divide this 1.011 which I have taken to be the maximum output value of this output wave, okay, which was around 1.011. Okay, now I have taken the cursor to here. Okay, so just see a 1.011 volt. Okay, so this one divided by 99.977 millivolt. When you will do this thing practically in calculator, you will get a value of around, I'm just going to divide it. So I will divide around 1011 millivolt divided by 99.97 millivolt. So the value is around 10.11. Okay, so you could do directly, you could use calculator here also. Okay, I have done it by the help of my phone. So if you want, you could do it here also. So my value of the output is 1.011 volt. So I will convert it into millivolt. So it would be 1011 millivolt divided by the value of the input signal max V peak of the input signal, that is 99.97. So it is divided by 99.97 millivolt. So just check here, the output is 10.11. Okay, so this is the practical value of output. Okay, now if you will check the theoretical output, a theoretical gain. Okay, then you will find the theoretical gain is simply 10 divided by 1. Okay, 10 kilo ohm divided by 1 kilo ohm, that is 10, and the practical we have got the gain of around 10.11. So that means that yes, we have got an approximate equal value. Okay, in the case of non-inverting amplifier, also inverting amplifier. Okay, the gain in practical and in the theoretical case are approximately matching. Okay, so there are some difference. Okay, but that is literally okay. Okay, so this was the end of the experiment. Okay, this is how you need to make the circuit. Okay, make a good circuit. Okay, so thank you for watching this experiment. I hope you understood that how to check the gain of op amp in both inverting and non-inverting.